Hello. In this video we're going to take a look at the example that is on page 101 in your textbook. It's 2-4b, how to solve a system of equations graphically. And I have here on my screen the two equations. I've written one in red and one in blue, and those coincide with the red and blue colors if you look at the digital copy of your textbook in Moodle. I've used the colors so we can kind of keep things separate and you can see what I'm doing on the screen here. What we're going to do to solve a system of equations graphically is we are going to put both of these two equations into slope-intercept form, and then we're going to graph both of them on the same set of axes, and we're going to look to see what the result is. If they cross in one place, then that point where they cross or intersect will be our answer. If they are different lines and parallel to each other, then we'll have no solution. If they turn out to be exactly the same line, we'll have infinitely many solutions, and our answer would be the slope-intercept form of either of the two equations, since they'll be identical at that point. Let's see what happens with this set of equations. If we take 2x minus y equals 6 and solve it for y, to put it in slope-intercept form, we begin by subtracting 2x from both sides. That'll give us negative y is equal to negative 2x plus 6. We don't want negative y or negative 1y, so we divide everything on both sides by negative 1, and we end up with y is equal to 2x minus 6. So if we graph that, we are going to graph the point negative 6, 0 and negative 6 I should say, the point 0, negative 6, that's the y-intercept. And then we're going to use the slope, which is 2 or 2 over 1 to find new points. So we'll go 2 up, 1 to the right, 2 up, 1 to the right, and we can repeat that as many times as we want until we're sure that we can get a nice straight line through all those points. I'm going to pop out a ruler here and see if I can draw a straight line through. The ruler really helps with these types of problems because it's important that we get things as accurate as we can. I've missed just a little bit there, but I think it'll work. But we want to try to get that point of intersection really accurately. And if we're not careful, and that includes using a straight edge, we won't always get that, and sometimes we'll read the wrong point as a result. If we deal with the second line now, we're going to solve that by subtracting x from both sides. Oops, keeps wanting to slide here. So we'll end up with 2y is equal to negative x plus 8, negative 1x if you like. We'll divide everything on both sides by 2, giving us y is equal to negative 1/2 x plus 4. So to graph that, we would need to graph the point 0 and 4, which is right there. And then our slope tells us to go 1 down, 2 to the right. 1 down, 2 to the right. 1 down, 2 to the right. And we can see as I went through there that we wrote over one of the red points. So that's going to be our point of intersection, but I'm still going to finish this out and show you what the graph looks like. So we are going to end up with a straight line right about there. Oops. That looks better. All right. So this point of intersection, let me circle that in a different color here. Right here, that is our answer. And we're going to write that in point form. So in this case, we're going to write that as the point 4, 2. And I know that because to get there, if I start from the origin, I'm going to go 1, 2, 3, 4 to the right, and 1, 2 up. 4, 2. If we go back and plug that into each of the equations, if we consider, for instance, 2 times 4 minus 2, that should be equal to 6. And 2 times 4 is 8. 8 minus 2 is 6. 6 equals 6. That one checks. Not a solution yet, though. Has to check both equations. So we go into the other equation. We'll have 4 plus 2 times 2. That's supposed to be equal to 8. And 4 plus 4 8 is equal to 8. There you go. That's how you solve a system of equations graphically.